Okay, so exponential. This is one option for exponential, and or this is another option. Okay. How do I know it looks like this versus that? What tells me?
Negative.
So this one is growing and this one is decreasing. What's the difference? This number is what? Greater than 1 growing, less than 1 decreasing. Okay? What's that y-intercept value at? 1. Unless, this could change if there is a multiplier. What about x-intercepts on these?
None. Because there's
An
an asymptote.
asymptote, so there's none. Domain left to right. So this graph could do anything. Range, what's the lowest height here?
1 to infinity.
Something to infinity, not 1. 0.
Wow.
It can get close to 0,
It's not on the
but it cannot be on 0, so then I put a
Wait, but it's
stop.
at 1.
It doesn't ever touch 0.
If you had 1, it would just be that.
Yeah, 1.
Am I right here? Am I below 1?
No.
Yeah. This height is below 1, below 1, below 1, below 1.
So, exponential will always be negative infinity to positive infinity for domain, and the range will be that, and then for the other one,
It's just,
it'll be the opposite.
right.
Always, 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 right?
yep. Unless like it's a word problem, then it just throws it all off, right?
Because
Because
word
then,
problems, I hate those word
because then you have to think about what's going on. And then we have log, or the natural log can look like this, or it can look like this. So this one is just the ln shape, but this one is just if I negative multiplier it, right? Okay, so let's talk about the y-intercept. Let's do all these things. The y-intercept. So where is it on this axis, the y-axis? There's none. Where's the x-intercept?
0, 1.
It's at 1. The domain,
0 to infinity.
0 to infinity, because it gets really close to the 0 line, but then goes to the right. And the range, so again, we kind of talked about the properties, mixed like that. Got it straight? Exponential, logarithmic. Okay, here we go. I'm going to graph this without even touching my calculator. This is exponential. Here we go. Is it option 1 increasing or option 2 decreasing? 2. It's the decreasing one.
How do you know that's exponential?
Because it has to the exponent. Something to an exponent. So it's decreasing, and we answered decreasing because this base is a half. So it's going to decrease. What is this y-intercept? Is it 1 or elsewhere?
1.
4.
It's at 4 because there's a multiplier, so it changes. Okay, so answering the questions. X-intercept. None. Y-intercept. 4. Range. Height.
Can we just write 4 for y-intercept?
Yeah, that's fine. Range, 0 to infinity. If you put a square bracket on that, I have to give you a point off. It does not touch the height of 0, so don't put square. Okay, y equals 5 log x. So now we're on the log side. So should we be normal or upside down? Just normal, because the multiplier is 5, so it's just still just positive. So it'll be something like that. The x-intercept is at 1. Multipliers don't change it because multipliers change heights.
So
And I can't multiply 0 to change it.
for the log, it'll always be 1.
Always. The only thing would be if there's like a digit that shifts, like that or something. Like that shifts it. Okay, y-intercept. None. Range is the infinites. And domain is the one that stops with a 0. Okay, we are back to an exponential. Okay, do you see a difference? Why I know exponential log? Okay, exponential, is it the grow or decrease? It's growing. How do I know? It's 1.2. It's a 20% increase. X-intercept, so on the x-axis, nope, never. None. The y-intercept, is it at 1 or elsewhere? It's at 3. Range, the height, you don't go everywhere with height, you stop at 0. Height stops at 0. Domain, going out sideways, you're going to go forever sideways. Left to right. And the last one, a negative log shape. So the last one is actually going to look like this. Log shape, negative log shape. X-intercept, 1. Don't have any other options. The multiplier does not change that. Y-intercept, so on the y-axis, never. The range, well, we can go down here and we can go up here. And the left, well, when we move left, we have to stop going left on this. Okay, have you nailed the properties? Those are your, that's it. Those are the big ideas right there. Those four options, okay? Okay, so we're gonna match these graphs. I'm going to talk about exponentials. Okay, so the exponential, there's a point in time where you have to stop its range. So an exponential, somewhere along the line, you're going to have to stop on its range, the height. Right? Remember this? The range would stop. Versus a log, you're going to have to stop its domain somewhere. Okay, and on ours it was always 0, but on these graphs it might not be the case, and here's why. I've added some after numbers, and then those after numbers can kind of change where you are. So we just have to understand this idea. Exponentials stop somewhere like this way, and log always stops somewhere that way. So out of these 4 graphs, I just want to go through and say, is it exponential or log? That's all I want. So what do you think about this? Are you doing a stop like this, flattening out? Or are you going up and down? Which option do you think you're doing? Do you look like this where you're stopping and going flat? Or do you look like this where you're stopping straight, up and down? On this one, I would say it looks like I'm stopping this way. Do you see it? The line is kind of flattening and saying, don't go past that. So it would be an exponential. Okay, this one, to me it looks like the pattern is stopping like that. Do you see it? Can you visually see that? So this one would have to be a log. Where's the restriction stop line on this one? Looks like this is the boundary line. So then this one is a exponential. And where is there a restriction boundary on the last one? Looks like it's restricted on this, which means that would make it a log. Okay, let's do the exponentials. So I have 2 exponential options here. Okay, here's my 2 exponential options. What is the base? When you look at this equation, what's the base number? Can you identify the base? Is it the 1.5, the 0.4, or the -1? Which part is called the base? This is called the base because that's the exponent is attached to that. 0.4, what would you think about 0.4? Are we going to grow or decrease? Decrease. looking at the last option, which is the base part, 2 is the base, so that would increase. So now we should match. We have only 2 exponential options here. So this is the decrease one, and this is the increase one. So I believe on your test I might have put this stuff without a calculator, that I'm not letting you use a calculator. So do you see how I'm reasoning it? I haven't touched my calculator yet. Okay, so now we have the 2 log graphs. They're both positive, so they're both going to curve like this. They're both positive, so they're both that shape. Let's talk about the x-intercepts. This one is the normal. It has a 1 x-intercept. This one is not at 1, so there was some kind of change that happened. So looking at your 2 options, can you reason which would go what? Which one seems normal and which one has a change on it that made that move? So to me, this one is normal, but this one has this like -1 after. What do you think -1 is going to do to something? It's going to make it go down 1, and that's what happened. -1 is going to make something shift down. So this one is that log that isn't at 1 because it shifted down. Okay, so again, I should check, but I don't think I'm letting you use a calculator. Okay, figure out the missing value. So I'm going to show you 2 things you could do. So the first thing you could do is you could go to Stat Edit. And then go 1, 2, 4, and 5. Do not type in 3 because you don't have anything for 3. So I did 1, 2, 4, 5. I put the numbers in. I did not put the 3 in because I don't have anything. Okay, good. I'm going to go Stat Calculate, and it told me there's an exponential function here, so it told me that. So I'm going to go down to option 10. So there's your equation. Sorry, I just don't like my time symbol. Okay, there's my equation. I'm going to go y equals vars, copy paste. And I'm not even going to graph it. I'm going to go straight to my table. And then here it is. At 1, we're at 80. At 2, we're at 60. At 3, we are at 45. But wait, I feel like I might have put this on a section without a calculator. So, here's what I'm going to do. From 80 to 60, what did I times by? Would you agree your timesor is smaller than 1? Because you're decreasing. You're getting lower and lower and lower. So you're timesing something that's decimally. If you want to know this way, what did you times by, how could you work that math backwards? 60 divided by 80. So 60 divided by 80 is 0.75. What's that? Do you even see that number? That's your rate. That's your multiplier rate. So I times by 0.75. So here we go. So I'm going to start this business out. 80 times 0.75 equals 60 times 0.75 equals, there's my answer. I'll try another one. Oh, look, that matches. Oh, look, that matches.
What if it doesn't match?
It will. Okay, so that's me doing it without my graphing calculator because on the test there's a section.
Wait, but then how do you do the math inside your head doing 60 divided by 80?
Oh, I would give you, I will let you use this then if you need. Yeah. Or it might be like, can you see that it's half or doubled?
I don't know, I need a calculator.
So let me give you an example. So for instance, could you guys get me the missing number on this chart? 12. So what did you do? You did what? What were you doing here to here? Times by 2, times by 2, times by 2. So you know what I mean? There's your missing number. What if I say, is this exponential? So for instance, would this chart be exponential, yes or no? Dun, dun, dun. Follow the pattern. Is it exponential? Yay or nay? No. Why? 2 to 6, what'd you do? Times by 3. 6 to 18, what'd you do? Times by 3. So it's good. I times by 3. Boom, I times by 3. We're good. What'd you do from 18 to 24? Not times by 3, right? I don't know what it is, but it's not.
So if it has a consistent pattern?
It has to have times by 2, times by 2, times by 2, times by 2, times by 2. It has to have that pattern, right? Every time. So this, do you understand it's a no? It was working until 18 to 24. That's wrecked the pattern.
So
Okay.
log is no pattern?
Yeah, it would just be different. I won't do the patterns, only exponentials. Okay, and then it would also be the same, like if it was a half, 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 right? Can you work it the other way, decreasing? Okay, here we go. We have a number of bacteria. So D is time in days. B 50 is the number of bacteria. Okay, always important to understand your variables. So the X is the time, the bacteria. Okay, so we are going to go to our calculator. We're going to be typing this in. So 50 times bracket, no, I don't need that, times 10 to the, you have to have this in brackets, x over 2. Gotta have that in brackets. Okay, can anybody tell me if this is growing or decreasing? Growing. What's your base? 10. It's going to grow. What's my y-intercept? My y-intercept is 50. Does anybody know what they'd already put on their window if it's going to have a y-intercept of 50 and growing? Big. 10 times larger, something's growing big. So let's go to our window. Let's go to our Y max. Bacteria can like rapidly grow. What do you want to pick? 1,000 to start? Boom, there it is. It's growing quick. Okay, in question 8 it says, what does the 50 represent in this situation? Do not answer me, it's the y-intercept. That's the graph. I'm saying, what does it represent with bacteria and time and all that? 50 is the initial what? The initial number of bacteria. Okay, so if you say it's the y-intercept, no points, because it's not the situation. You didn't tell me anything about the word problem. If you say it's the initial number, I don't know, the initial number of what, days? You have to write down what it is. Is the bacteria increasing or decreasing? We wrote that it was increasing. How did we know? The base 10. Bigger than 1, so we grow. How many days will it take for you to reach 800,000 bacteria? So tell me this number, did I give you an X value or a Y value? Y, so we do a Y2 intersect. Y2, I gotta go back to my window. Yikes. Oh boy. 1 million? I'm doing my scale big time here as well. I went to 1 million. I'm doing 100,000 scale. I have no idea what's going to happen here. Is it going to fit? Yep. Okay, we got our intersection, enter, enter, enter. Okay, let's talk about domain and range because I feel like that's our problem. Let's talk about domain and range. Domain is the time. Where did we start out with our time? Days. What was the first day we started counting with? On day 0. Were we on exactly day 0? Yes, we started exactly at the start. Was there a point where we had to stop? No, we didn't stop our experiment. And the range, so that's the population. What was the lowest population we were at? 50. Was that exactly? Yes. Was there a point of time where we stopped counting our population? No. Okay, and the last example here. We're doing video games released in the year 2000, and it steadily slowed as time moved on. The table shows the number of games sold in thousands from the years. So let X represent the years. Let Y represent the number of games sold in thousands. So it's not just that they sold 142 games, they sold 142,000 games. Let X equal 1 for the year 2000. So that's going to be a 1. So then this would be a 2, 3, 4, 5, 6, 7, 8, 9, and a 10 and 11. There was no skips, right? We didn't skip one.
How do you know when you skipped one?
Like if this was 2002, but then this was like 2005.
Oh.
That's how I caught you on that last test. I didn't just go 1, 2, 3, 4, 5. I did, like there was missing. Okay, so go ahead, stat edit stuff.
Do we do the 1,000 or just 1?
No, just do the number. We'll do the 1,000 if we have to answer. Okay, so you're gonna have to do some stat edit stuff in your test. Okay, we're good. Stat calculate. Nope, no, I'm not there yet, just kidding. Let's go plot, activate, zoom 9. So this is my plot. What are you thinking? What kind of shape is it making? We got two options. Is it an exponential shape or a log shape? It's a log shape. So we're going to go stat calculate. Remember that ours doesn't do log. It does ln, natural log. For you French immersion, the log au naturel. The ln, log, that's how I always remember it. You always need to write your equation down. That is part of show your work. That's me showing my work. There's my equation. How many of you forgot y equals on your last test when I said write an equation? Y equals vars stats equation to get it copied and pasted. So this is exactly what logs are used for. Something that's growing, but it's growing slowly, right? It grew, but then it kind of like, it was a video game, so it was really popular, but then it like leveled off and it's just barely growing, right? Y equals deactivate. If the games continue to sell at this rate, how many games are we going to sell in 2015? Okay, so that is a year. So that is an X value. So I'm going to go trace. This is showing my work. I'm hitting trace. But I'm not doing 2015. You gotta, it's the X value, just 16. Okay, so I'm gonna trace 16. And when I hit trace 16, it gave me a quit. We all remembered why. Expand your window. I'm gonna go to 20 so that 16 is in that zone. Now my mouse can go there. Round to the nearest 1,000. So like this is the number. That's the number that I'm getting. Like if you thought about the number of games. So we're gonna go 171,000 games, like that, for rounding, because it's to the nearest 1,000 spot. Okay, let's do a domain range, because I think, again, it's the cause of problems. So the domain is the years. So guess what? This game was only released in 2000.
So what?
So and we used X of 1. So we have to just start there. We can't be below that because the game didn't exist. So 1, and I don't think there's a stopping point, right? And then the range, well, what's the lowest amount of games sold? So like if I drew this out, it'd be like that, but we're saying we're not taking that part of the graph. So we will only start there at 142 and beyond.